I really pleased for this last talk of the day to give the floor to Karine Chemla, who will talk about Leibniz, but from the point of view of Poncelet.
Dear Eberhard, I know that I should not compute for how many years we have known each other, but it is nevertheless the case that we have known each other this year, and perhaps even this day, for 40 years, since we met at Syrma in 1983. And we have remained friends for so much time that I'm really delighted. First of all, before I say a few words, I wanted to present a solution of continuity between the previous talk and my talk, since this was taken at Oberwolfach when the three of us organized a meeting in 1994. So close after, 11 years after we had met. One has spoken a lot about all the work that you have done. We are all grateful to you for all that you have done from a scientific viewpoint. I would like to emphasize particularly what also has been emphasized by so many people, and that is your human qualities. I think that I have benefited, like so many people in this room, from your benevolence. I have benefited from your humanity, from your encouragements, and from your generosity. There are so many people, when they see that you are doing something, they wonder why they did not do it themselves and why you did it. And you are certainly not one of these people. And for this, and for all the support, thank you wholeheartedly. I think that in this way of encouraging so many people, as we have heard, I've discovered all the people you have encouraged, and they made all the same testimony. And I think this was a huge contribution to shaping our field. Encouraging younger people is really something that is essential, and you have shown us the way. Thank you for that. So I thought I should do something for you, and hence I have chosen to return to Poncelet. In fact, someone with whom now I'm working with Bruno Velost, and to return to Poncelet, asking a question about Leibniz, for reasons that are absolutely obvious. I'm sorry? Okay. So the question that one often, and the connection between Leibniz and Poncelet that is the most often quoted, I would say, deals with his so-called principle of continuity. So we know that Poncelet, with his treatise of projective properties of diagrams of figures, published in 1822, was trying to achieve generality in geometry that could compete with generality in analysis, generality, a topic on which we have also cooperated. And I know that I'm always late when I'm editing books, and I still remember Eberhard telling me, please, Karine, please publish the book before I die. The book is out, and I'm relieved. So Poncelet had two main principles, put forward two main principles to achieve generality in geometry. Was one the principle of projection, namely if you have properties that are by nature invariant by projection. You can claim these properties when you have proved them on a very simple configuration. You can claim them for any configuration obtained by projection. But he has another principle that is far less understood, and I think until today, which is the principle of continuity. Just to remind you of this principle, first, Poncelet considers a geometric object as being an arbitrary figure in a position that is general and in a certain sense indeterminate among all those that the figure could take without violating the laws, conditions, and links that persist between the various parts of the system. So this is the general figure, the figure for Poncelet. And about this type of figure, Poncelet asserts a principle. Suppose that one found one or several relations or properties, either metrical or descriptive, that belong to the figure. And one finds these relations, these properties, using the ordinary explicit reasoning based on the state of the figure as we have it under our nose. If, keeping the same data, one makes the figure vary by imperceptible degrees, continuity, one is tempted to believe, or one applies to some parts of this figure a continuous motion, here is the continuity, in fact a motion that is arbitrary, is it not obvious, asks Poncelet, that the properties and relations that one found for the first system, the original one, remain valid for the successive states of the system if, however, one pays attention to the particular changes that might have occurred, and so forth and so on. So we have a figure, we prove something, we shift the figure in a continuous way, it seems to say, at least, this statement seems to say, and one can state the same property, the same relationship on any figure that has been obtained, even if things had disappeared from the figure and so on. So when Cauchy saw this, he criticized it, and many people criticized this principle, driving Poncelet mad, but this is not the story today. The key point is that Michel Chal, as we know, wrote an aperçu historique on the history of the origin and the development of methods in geometry, in which he tackled the history of geometry from the viewpoint of generality, in which he rethought some methods, and to which he added historical rules. So one thing Chal does is precisely rethinking the principle of continuity. First of all, Chal attributes the main idea to Gaspard Monge. First thing that is not so nice for Poncelet, but in fact Poncelet, in unpublished writings at the time, had done the same. He too had attributed the same, the original idea to Gaspard Monge. So for instance, Monge had used the principle for the theorem that if we have cones circumscribed to a surface of degree 2, and if these cones have their vertices on a straight line, then the planes of contact, the planes of the contact curves of all these cones share a common straight line. And Monge had proved this with a line outside the surface. So you have the cones whose vertex go along the line outside. Then the two planes that touch the surface of degree 2 touch the surface in 2 points that are the same, and the plane in which the intersection lies is the same, and hence the common straight line. And then Monge asserts the property for any line with respect to the surface of degree 2. And then Chal offers a reconceptualization of the principle under the name of principle of contingent relationship. But what is more, Charles adds a note among the many notes, historical notes that he adds to the Aperçu historique on the law of continuity and the principle of contingent relationship, where he compares the expression principle of continuity and principle of contingent relationships, the one he has introduced. One could use one for the other, and yet there is something essentially different between the two. And this is why I shall prefer principle of contingent relationship. And this thing he will explain by claiming that, so once again claiming that Poncelet has done something that was done by someone before Poncelet, that the principle of continuity goes back to Leibniz, who, he writes, was the first to propose it as expressing clearly this law of nature, that everything is carried out by nature through degrees that cannot be perceived. And hence the question, does Poncelet's principle of continuity actually come from Leibniz or not? So the first question I would like to address very briefly, when did I begin?
10.
Thank you. The first question that I would like to address is, how could Poncelet read Leibniz? The fact is that Poncelet was a student at the École Polytechnique, which was established right after the French Revolution. And one of the best things that happened during the French Revolution is that all the aristocrats were deprived of their treasures, including books. All the convents, ecclesiastic institutions were deprived of their libraries. There were big depots made, and people who were in charge of libraries and institutions could go to these depots and pick up books. This is what the second librarian, I will not mention the first one, François Perard of the École Polytechnique, wants to find books and to create a library that he wanted to be a library of reference. So he mainly had two sources for creating the library. One was that the French armies were at war with armies throughout Europe, and when they were victorious, they confiscated books that they brought back to France, and Perard could get lots of books from Belgium that entered into the library of the École in 1795, among which, coming from Belgium, the Opera Omnia of Leibniz. I'm quoting the paper that Luigi Pepe has devoted to the books taken from Belgium, and the Commercium Philosophicum et Mathematicum, that the exchange between Leibniz and Johann Bernoulli. Moreover, in the depots that he could visit and from which he could pick up books for the library of the school, Perard found, that's again from Pepe's article, Pascal's opera, in which was included the letter in which, and the notes that Leibniz had taken on Pascal's essay for les coniques. This is the direct access. There were also indirect accesses, since we know that as a student at the École Polytechnique, students, professors were encouraged to use the library. They were encouraged to find methods, find problems in the books. And we have a testimony by Poncelet himself, who recalls that together with Mr. Guidon, who belonged to the group, to the same brigade, the same group of 20 students who were studying in the same room after the general lectures, with Mr. Guidon, who belonged to the same study room as Poncelet did. He worked during recreation hours reading Lagrange, calcul des fonctions, and mécanique analytique, and so on. So we have lots of testimonies that students were encouraged to read, and we know that Poncelet was one of those who spent much time reading thanks to the library, Lagrange, calcul des fonctions, abounding in references to Leibniz. After completing his studies at the École Polytechnique, Poncelet goes to l'École d'artillerie du génie de Metz, where he has, as a professor, Jacques-Frédéric Français. Then he goes for Napoleonic Wars. He's made prisoner in Russia, in Saratov. He returns to Metz in 1814, where he's in contact with Français, who, we have testimony about that, lends him books from the library of Arbogast, which Français inherited. So Arbogast was one of the figures of the French Revolution who was involved in the institutions of the French Revolution, and he was one of those who went to the depots, went to identify manuscripts, books, and took many for himself, which Poncelet could read until 1823, when the library of Arbogast was sold. And we have a small piece of evidence about what was in it, and again we see Leibniz. How could Charles read Leibniz? First of all, he was too a student at the École Polytechnique, but we also have the catalogue of his scientific library, and we can see that Charles had many books by Leibniz, or with books in which there were things that had been published by Leibniz. So, if we look at Poncelet's works, for what does Poncelet refer to Leibniz? So, just to give you a very brief idea of what we have for Poncelet before I analyze where he quote Leibniz and how. In addition to the 1822 treatise that I have mentioned, at the end of his life, Poncelet feels that his geometric works have not been enough recognized, and he publishes all the notebooks he had taken in Saratov when he was in jail. He republishes all the notebooks he had written in Metz as he was officer, reading Arbogast library. That was the Application d'analyse en géométrie that he wrote these notebooks before the publication of 1822. And after having published all these notebooks, Poncelet republishes the treatise of 1822 with some additions and corrections, and a second volume with the papers he had published after the treatise, and lots of private documents that he made available. So, interestingly, if we look at the treatise, the only reference we find to Leibniz is a reference to what Leibniz had taken as notes on Pascal's Essai pour l'économie. And Poncelet refers this historical piece of evidence to Brianchon, who had written in the correspondence de l'École Polytechnique a paper in which he made clear that we had evidence about Pascal thanks to Leibniz and so on. Brianchon, another student at the École Polytechnique. So, in the treatise, the references to Leibniz are really restricted to what deals with geometry. For the notebooks of the Saratov period, Poncelet claims to have been without access to any books, and in fact we have no references. Only we have references in the notes that Poncelet added later when he published his notebooks. However, the thing is different when we look at the notebooks that he published between the moment when he came back from Saratov and the treatise, because there he refers to Leibniz for things in dynamics. He refers to Leibniz for the idea of having an analysis that would take situation into account, the analysis situs. He refers to doctrines in calculus of Leibniz and Newton. And most interestingly, I hope I have time to go back to this piece that I have highlighted, he refers to Leibniz as participating in the debate on exponentials and law of continuity. So these are the various pieces that Poncelet was aware of. Okay, so how did Charles, in his historical note, shape Poncelet as a successor of Leibniz? So I return to this slide that I have shown you, where he emphasizes the fact that the principle of continuity would go back to Leibniz and would state that it's a law of nature that claims that everything in nature is carried out by degrees that are, I'm sorry for the translation, imperceptible, insensible. I don't know how to translate this. And then Charles emphasizes that this principle, in his view, hence has its origin in the infinite, has the origin in one principle that Leibniz expresses, that when the difference between two cases can be diminished to be smaller than any given magnitude in the data, then, or in anything that is given, then one must be able to find this difference also as small as any given data in what is found out, in what results from the data. So this idea that is connected with reasoning that deal with quantities that are smaller than any given quantities. And he states that the origin of the principle of continuity in geometry then dates back to the origin of the science, as Lacroix states it, who finds it, who reads it in Euclid's Elements when, in proposition 2 of book 12, one attributes to the circle the property that one has found in polygons, given that polygons differ from circles by can differ from circles by magnitudes as small as was given. This is what Leibniz Charles refers to as the law of continuity based on Lacroix returning to Leibniz. So, the ancients, Charles claims, used the law of continuity as a means of discovery, but did not use it as a means of proof. Who used it as a means of proof? Poncelet. But since Leibniz, it was adopted as an axiom and used continuously, daily in mathematics. Okay. Poncelet, in one of the notes that he adds to the papers he publishes at the end of his life, protests naturally against Charles' attribution to Leibniz of this principle of continuity. I don't understand why Mr. Charles, who mixes up the principle of continuity as I have defined it in my memoir of 1820 that I presented to the Académie des Sciences, he confuses it both with what Poncelet refers to as the infinitesimal continuity that Leibniz introduced or used, and I will not deal with the other branch of the confusion, which is with the principle of correlation of figures that Carnot had introduced. So, interestingly here, Poncelet refers to that in which Charles finds the origin of his principle of continuity as the infinitesimal continuity. And this points out precisely to the key point that makes the difference between Poncelet's notion of continuity and this notion of continuity that is involved in Leibniz continuity. And this is where I would like to turn to how Poncelet understands continuity. You have to understand that now we are in a position in which Charles was not, because we are in a position in which we can read many more texts that Poncelet wrote than Charles did. So Charles only had the treatise of 1822 and some papers, but we can now understand much better what Poncelet meant by continuity. And I think the title that remained, Principle of Continuity, was the main reason why there was this confusion. But I think that we can understand much better what Poncelet meant by continuity, which is completely different. So we have several texts on the basis of which we can understand this, and believe me, this is not an easy task to understand what Poncelet means by continuity. He begins dealing with this issue in the third notebook that he published in 1864, written during the winter 1815-1816. He goes on thinking about this in the fourth notebook, Considérations philosophiques et techniques sur le principe de continuité dans les lois géométriques. He presented this paper, had this horrible report by Cauchy, did not publish it, but then in the end presented it at the Société des Lettres, Sciences et Arts de Metz, thanks to which we have a report by Bergerie on the memoir, which contains something interesting, and naturally we also have the treatise itself. So in fact there is a history of the principle of continuity according to Poncelet, and this history still needs to be written. But I would like to point out one key fact. And this key fact, I will begin showing it to you, relying on the report that Bergerie, president of the society at Metz, writes. So the author, Poncelet, proves that geometry is not inferior to analysis. It is not inferior in the sense that it would only reason on a state of the system that is very particular. Poncelet suggests that in geometry one should think, one should do reasoning on the basis of a system, any part of which would not be determinate in magnitude, as we do in analysis when one uses general signs. And as we do in descriptive geometry, I skip this. And this is where we have a very interesting occurrence of the verb continue. The results to which one would reach. The laws one would establish for this system, this general system, would continue in all the other states of the system. And this sheds light, the idea that you have results, that you have law that continue in any other state of the system, sheds light on the real name that Poncelet had given to the principle of continuity, which is the principle of continuity or permanence of mathematical relations of the figure magnitude. And he adds in a note of 1818, this expression is to be found and discussed in the fourth notebook from the winter 1819. In a note, we will see how this definition is connected with the idea one has generally of continuity. In the end, this is the last sentence, we will here use this sentence, principe de continuité, only with the aim to abbreviate discourse. And when he replies to Cauchy's report, who misunderstood continuity, Poncelet writes again, I abbreviated this whole expression, principe de la continuité et permanence des relations mathématiques de la grandeur figurée, I abbreviated this into principle of continuity, but this is what I meant. Now, about, and I'm going to finish very soon, about Poncelet's idea of continuity, we have the note, which is a very complex text, so I will not dwell on the complexity of this text, in which he discusses, in particular, whether exponentials and logarithms are continuous functions and the law of continuity. And you see, he writes, quant aux courbes dites transcendantes, je citais divers exemples où la continuité semble cesser d'avoir lieu en des points pour lesquels leur cours éprouve un changement brusque, tout au moins apparent. And when he discusses the logarithm of negative numbers, he insists to say that for him, the issue is to determine whether the logarithm is continuous or not. The issue is to determine whether the logarithms of negative numbers are the same or not as those of positive numbers. This is what he refers to as the continuity of the logarithm. And for you to understand clearly that there is a problem in his understanding of continuity, he criticizes he criticizes Cauchy for believing that the tangent function is discontinuous between 0 and pi. For him, the tangent function, from the viewpoint of his notion of continuity, is perfectly continuous. So, we have here an understanding of continuity that relies on the idea that an object is defined continuously if there is one and the same law that is defining this object, but since he doesn't want to do it with analysis, he's not going to use equations to define this object. So this is the problem that he's facing when he introduces the permanence of the law that is the permanence of the relation, the mathematical relationships that are defining a system. So I think I've been very sketchy because time is limited, but I think that it is a huge mistake because of the notion of the expression of principle of continuity to conflate Leibniz principle of continuity and Poncelet principle of continuity because they have completely different meaning and they have completely different uses. Thank you very much.